Picking up right where we left off, let's move down. Still talking about percents, but now we're going to convert the other way. So convert the percent to a decimal and convert the percent to a fraction. Okay, so we start off with part A, 50%. So we're going to convert that to a decimal, and then we're going to convert it to a fraction also. So let me get my piece of paper here um, so we don't reveal too much. Okay, so converting it to a decimal, well, you just do the opposite. So right now, think of the decimal place as right there, and we're going to move it back 2 positions. So the decimal version is 0.50, or you might just think of it as 0.5. We don't need that 0 on the end. Either way, perfectly fine. Okay, how about the fraction? This makes sense, right? Just do the opposite of what we did before. So given a percent, move the decimal back to the left to get the decimal version. How do we get the fraction, though? Okay, let's talk about that. Here's what we're going to do. The word percent, if you see, you break it down and you see the word cent, right? Cent means 100. That's where that part of the word came from. Like, a penny is a cent, right? 1/100th, or a century is 100 years. So, and that's why we move the decimal place twice, but it's also going to help us with the fraction. So what we can do, take the percentage, right, 50, and divide that by 100. And that will get us to the fraction. Now we want to reduce it, so we have the reduced fraction, but that's how we're going to start. Just whatever the percentage is, put it over 100. It's always 100 because it's a percent. All right, when we reduce that, you might think, oh, I'll divide both by 50, get 1/2. You could throw that in a calculator and have the calculator do it for you too, if you weren't comfortable. But if we think of dividing both top and bottom by 50, we'd get a 1. Dividing by 50 here, we'd get the 2. So there's either of these work for the decimal, and there's the fraction. Okay, let's see another one. Oh, looks like this page came to the bottom. I've got one more. Let's do 6%. Well, to get the decimal, we're going to move the decimal place twice. So right now the decimal is here, and we're going to go 1, 2. Now when we move it that second time, we'll just fill that in with a 0, 0.06. Okay, and the fraction, well, same approach as a moment ago. We're going to put it over 100. So 6% becomes 6 over 100. But then we want to reduce that fraction, and it turns out we can divide both top and bottom by 2 and get 3 over 50. Or if you weren't comfortable, you could go 6 over 100 and then hit that double arrow, and the 3 over 50 is right there. Hit the double arrow again, and it'll give you, oh, the decimal, and what do you know? Yep, 0.06. Cool. Hit it again, converts it back. It's kind of a really, really nice feature. All right, moving on. Now these can be challenging for lots and lots of students, translating into mathematical notation. Now this is going to be big in our class. It's not that we're going to be translating things so much, but we're going to be reading a lot, right? Statistics problems, and as we get deeper and deeper, it becomes more and more true. They typically be a few sentences. So a typical statistics problem is like a short paragraph of information, and they'll say, okay, what do we do with this? Or they'll ask a specific question, and so we just need to practice interpreting written language into its mathematics, right? It's all about it's like a reading comprehension. that's going on in a very mathematical sense. So this is a good way um, to try that out. All right, in part A, we're saying the product of 5 and a number, and we're going to translate that into math symbols and make a mathematical sentence. Okay. Well, when you see, I've underlined a couple parts to that. When we see the word product, think multiply, right? I'm taking the product of two numbers, means I'm going to multiply them. So the product of, okay, so I know I'm about to multiply 5 and something else. What's going to get multiplied? Well, 5 is one thing, and then a number. And we see a number, that means, well, it could be any number. They don't tell us. So we're going to represent it with the variable x. So the product of 5 and x, or even you might even read this, multiply 5 and x. Well, the way we do that, we just write 5x. Now, it wouldn't be wrong to write 5 times x. That'd be perfectly fine as well. But we usually don't put that dot between a number and a variable. We usually just write that as 5x. Either one are correct. But this one is far more typical. Okay, let's do something a little bit harder. Now this one is really going to push us. The sum of the product of 10 and a number squared and twice the number. Okay, let's just let that sink in for a second. Let's read it again. The sum of the product of 10 and a number squared and twice the number. What is going on here? That's a lot. It seems like just a jumble of info. So notice in this problem, they name two operations, right? There's the sum, which means to add, and there's the product, which means to multiply. Well, how are they allowed to say the sum of the product? Okay, well, if we keep reading, because they wrote sum first, the sum is like the bigger picture concept. And then within that, there's a product. Okay, so when you read the sum of, then we're looking for, okay, then what are they adding? What are the two parts being added? And the first one is the product of 10 and a number squared. That's the first part in the addition. And the second part of the addition is twice the number. So it's the sum of this and this. Okay, now we got to break that down. Okay, so I know, that this first part's going to be added with this, but then now let's break those. Okay, so here, the product of 10 and a number squared. So when you see the number, again, that's x. The number squared is x squared, and we're going to be multiplying that with 10. Multiply 10 and x squared. That's the first part of the addition. Okay, then we add twice the number. Well, twice means to multiply by 2, and again, the number is x. So here is the mathematical notation. We've got the product of 10 and a number squared. We've got twice a number, and then we're adding those. So it's the sum of 10 times a number squared and twice the number. 10x squared plus 2x. Those are challenging, no question. You might want to back the video up and listen to that whole thing again. Or try one out on your own, see if it made sense, see if it landed. Okay, I've got another one here. Now we're going to introduce a new element. A less than. A weight of less than 32 ounces. Okay, let's highlight that. Do you guys remember the less than symbol? So maybe I'll write these out here. So there are a few. So there's less than. There's greater than. Then there's also less than or equal to, if it might be equal. And there's greater than or equal to. Okay, so we've got the less than. All right. Now, when they say await, that's like, well, a little breeze, I think, revealed the answer. Um, that's an unknown number. We don't know what the weight is, so we need a variable there. And then it's going to be less than, and we're just going to say 32. So here we go. I'm going to use the variable x, await, some weight, some number is less than 32. You could use w there, nothing wrong with that. W less than 32. Okay. I've got another one. Pulse rates were between 55 and 86. Pulse rates were between 55 and 86. All right. So when you say, okay, pulse rates, well, that's some number. So we'll use a variable for the pulse rates between 55 and 86. Okay, that's interesting. So it's caught in the middle. Here's what we're going to do. We're going to put x between the 55 and the 86, and then we're going to use less than symbols. 55 is less than x, which is less than 86. So if the pulse rate is between these two numbers, then that's the notation to show. X is 55 is less than x because x is bigger than 55, but then x is also less than 86. It's somewhere in the middle. Now you might be asking, hey, how would I know here to use a less than and not a less than or equal to? Wouldn't this make sense as well? Kind of depends on the way that you read it. And in this situation, in this problem, I would accept either one. Kind of depends on your interpretation of between. So if you read between as it's got to be between them, and it can't actually be one of them. That's the way I read it. No sarcasm implied. If a number is between them, like if it's equal to, that's, I guess I don't think of that as between. But I could see how somebody else might read that. Well, if it's 55, and I certainly, there are situations where people say between, and they certainly imply that they could equal. So it turns out that's really not going to be much of an issue at all in our course. Some circumstances, we're going to see things just like this in the course, and it will be clear from the context which one it needs to be. There will be no doubt about it, and like it'll be like, well, when I'm doing this sort of a problem, it's always this. It's always the, and that's just going to be clear from the concept. Or in other cases, it might equal. I think I would phrase this differently if I wanted to imply it could equal. Although here okay, kind of the point I'm trying to make is, if you lean towards this, or if you're a person that leans towards this, that's not going to be an issue for the problems that we're going to see later. Okay. All right, finally, we get to the graphing on a number line. And let me show you the first one. Okay, so we're kind of building on this idea in the first example of the between. So in part A, x is between -3 and 4, or it could equal them. We've got the or equals now. -3 is less than or equal to 4, and that is less than, or excuse me, -3 is less than or equal to x, and x is less than or equal to 4. Okay. So what would that look like on a number line? So, well, let me show you. If I make a quick sketch of a number line. Okay, so I've got my number line there, and I've marked 0 at the middle. And then it's hard to see because I've got the graph, but okay, if that's 0, then I've marked off 1, 2, 3, 4, 5. And going back in the negative direction to the left, 1, 2, 3, 4, 5. And then I'm going to say, okay, on that number line, let's indicate where -3 is, and let's indicate where 4 is, and we're going to shade all of the x values represented here. So it's all of the values between. And we're also going to include the endpoints because it could equal them. So -3 is included and 4 is included. When we want to indicate that we are including a number, we put these brackets, these square brackets. Okay. Now, just to go one step further, there's this thing called interval notation. And interval notation looks a little something like this. Interval notation is like a shorthand for the number line. So people realized, hey, if we don't want to draw a number line and shade it like this, is there a faster way we could communicate the same thing? And they realized, hey, why don't we just write those numbers where it starts and where it stops with a comma, -3, 4, and then we'll put those square brackets around the ends, and people will know, it's like this right here and this mean the same thing, right? The value of the variable x is between -3 and 4, or it might include the -3, or it might include the 4, because we got the square brackets. Or it could be any number between them. And last example, in part B, let's try one without the or equal, because there's a different symbol if we don't equal the numbers themselves. So we'll see that here. X is greater than 2. Let's graph that on a number line. Okay. Well, here it is. So I'm starting off and got my line, got arrows on each end. I indicate a 0. Then I just count a few in each direction, right? 1, 2, 3, 4. 1, 2, 3, 4. That'll be good. And let me indicate the 2. And all right, so we're going to shade, since it's greater than, we're going to shade everything bigger than 2. So that's definitely there. But now we want to be clear that 2 itself is not part of this, right? Because x has to be bigger than 2. It can't equal 2. So to do that, we put this round parentheses pointed in the direction of the shading like that. So then people know that's a way to indicate, all right, everything up to here, but not to itself. All right. And what would be the interval notation? Here it is. Well, you're going to start at 2, right? And it's got the parentheses. So kind of in the same way we started here at -3 with the bracket, here we start at 2 with the parentheses. And because it never ends, it goes on and on and on, then we write comma infinity. And the rule for infinity is you always use a parentheses. And kind of part of that logic is, well, kind of like the 2, we don't want to include 2 itself because it's all the numbers up to but not to. Infinity, you can never actually get there. So it's all the numbers up to infinity, right? But you're never actually going to reach that. It's kind of the thinking. Okay, that is what I have to say on the pre-algebra basics. Hopefully that helps you out wherever you were stuck in that handout. And hey, we recognize we have people coming into this course from all kinds of levels. There's no prereq, so I'm not going to assume that anybody, I'm not going to assume any level of skill coming into the course. These are the things that we need coming in. As we see more things later on, I'm going to take the time before we do those to break it down and tell you just exactly what you need to know. So if you understood a lot of this already, and then I think that's wonderful. If you were, if there are some points that we need to address, before, hey, let's do it now, and then we'll be ready to rock it as these situations come up later on. So, okay, that's all I've got to say.